Today we're going to start off with addition and subtraction. First, a few definitions. What is addition? Addition, which is represented by the plus sign, is a process of increasing one number by another. So let's say we have 5 plus 3. We're increasing 3 by 5 or 5 by 3. As we'll see in a future video, it doesn't really matter which one you start with, but it's a common practice, I suppose, to start with the first number and increase it by the second number. So start with 5, increase it by 3. These two numbers, 5 and 3, are called the addends of the problem. Basically, they're the two numbers that you want to increase. You want to add together. Now, this is equal to 8. The result of this is 8, and that too has its own name, the sum. The sum is the result of the addition problem. Now, quick question, how do we know that the sum is 8? Well, that's where we get the process of addition. We can use a number line. For one-digit problems, it's best to use either a number line or an addition table to memorize these first two problems. Once you get that, there's multi-digit addition problems that I'll talk about later in this video. But first, the number line. Let's say we have the numbers 0 all the way through 8. It's important to use a number line to get familiar with addition because after that, it'll sort of become easier to do it in your head or even on paper. So this is a rough number line for now, but the addition problem is basically you start with the first addend. So in this case, it's 5. Then you move some number of steps, either 3 in this case, but like the second addend basically. Second addend number of steps. In this case, it's 3. So 1, 2, 3, and we hit 8. As promised, the result is 8. The sum would be the number that you hit at the end. So this is how you do a one-digit addition problem. How do you do a two or even multi-digit addition problem? Well, let's say we have something like 261 plus 28. How do we solve this? So you can write it vertically, which is preferred, or you can write it horizontally, like we saw with the one-digit problem. It's a bit harder to solve it horizontally, so even if you see a problem that's horizontal, it's best to turn it into a vertical problem. You just put the second number underneath the first, and then you put a plus sign next to the second number. So how do we solve this? First, all you look at is the ones digit. We see 1 plus 8, and we know that's 9, either through a number line or an addition table, or you just memorized it already. So let's say it's 1 plus 8 is 9. So far, so good. Then you only look at the second column, which is 6 and 2. 6 plus 2 is 8. Good. Now you look at the third column only, and you get 2 plus nothing. Well, I mean, there's nothing, so it's just 2. 289 is our answer. So you just go column by column until you have added all of the columns together. Now, there's a twist to this, and we'll explore that a few videos from now in an advanced addition and subtraction video, and that's called carrying, but I won't get too ahead of myself. We'll take that to the next few videos. Now, we're going to switch topics to subtraction. Subtraction is similar to addition because it's a bit related, but it's decreasing one number by another. So we have 5 minus 3. This minus sign is the symbol for subtraction. This first number here is called the minuend, and the second number here is called the subtrahend. These two numbers, sort of like the addends, are part of this problem, but in the previous problem, in addition problems, you can switch the two numbers and you'll still call them addend and addend. They'll still be the same value, the same sum. We'll talk about why that's the case in a future video again, but for subtraction, you can't do that. You can't switch them around. Minuend and subtrahend have to be in their corresponding places. If you have 3 minus 5, that's a completely different problem. Now that we have that out of the way, what is the result of this? Well, it's 2, and this is called the difference. Like how the sum was the result of the addition problem, the difference is the result of a subtraction problem. And the reason why I said this is related to addition is because it undoes addition. You can imagine if we have the 3 on this side, instead of minus 3, we have a plus 3 on the other side. You get 5 is equal to 2 plus 3. So this is basically undoing what this addition problem just did. That's why it's sort of related to addition. Again, how did we find that 2 was the difference? Again, we can use a number line. This time, we only need to go till 5. And it's best to use a number line for subtraction rather than a table of sorts, because number line is the one you also use with addition, so you can see how it sort of undoes it. In this case, we start with the minuend, we start with 5, and we go some amount of steps to the left. Instead of to the right, we go to the left. We go the subtrahend amount of steps. In this case, the subtrahend is 3. So we go 1, 2, 3. 3 steps and we reach 2. This final answer would be the difference. Again, similar to addition, we start at one number and go some amount of steps in one direction. For addition, it's right. For subtraction, it's left. That's the key difference between them. Now, we can also do multi-digit subtraction. Just like we did multi-digit addition, we can do multi-digit subtraction. Let's say we have 976 minus 124. How do we do this? Again, we look column by column. What's 6 minus 4? That's 2. No problem there. What's 7 minus 2? That's 5. And what's 9 minus 1? That's 8. Again, if you have trouble with this, most people have trouble at the start. You can just use a number line to get practice with this until you can memorize what 9 minus 1 is. So we get our answer, 852. This is the difference. Similar to carrying with addition, an advanced topic in addition, we have something called borrowing in subtraction. Both of these are a bit advanced for pre-algebra, so I'll be covering them in a future video. But for now, this is basic addition and subtraction. Next time, we'll be talking about basic multiplication and division, 2 more operations that are essential for math. So, I'll see you then.